All right, so here's notes 2.8, fraction slopes with graphs. You should always remember that all slopes are fractions. And with that, if we have like the 2 as a slope, okay, to make it a fraction, you just put it over 1. So anytime you have just a number, to put it over 1, and then you have a fraction. Now the top of the fraction is the math for your y's. The bottom of the fraction is the math for x's, okay? And then for your movements, the top, your y's are up or down. Your x's are right or left, okay? So looking at the first word problem, Julie had to be absent from school and had a lot of missing work. She already completed 4 assignments she saw in Google Classroom. On her first day back, she was really overwhelmed, so her math teacher told her to just complete half of an assignment each night and then turn them in as she finishes them. So we have this equation y equals 4 plus 1/2 x. Well, the 4 represents the assignments already completed. The 1/2, or the plus 1/2, represents how much she finishes each night. The x represents the number of nights. So we're going to use a calculator to show her progress. So what we're going to do is we're going to take this 0 and it replaces the x in our equation. And let's type that in. So we got 4. Let's do that again. So this time we're talking about 1 night. So let's type that in. Well, now we get 9/2. Okay, let's type in for 2. Okay, look, we get the number 5. That's a nice number. Let's do 3, and I'm going to show you a shortcut. Well, that gives you 11/2. That's an ugly number. Let's do 4. Well, that gives you 6. Let's plug in 5. Well, that gives us 13/2. That's an ugly number. And let's plug in 6. Oh, look at that. That gives us a nice number. So in number C, or letter C, it says she wants to do her progress on a graph to predict how long it will take her to finish the assignments. But it's confusing because of those ugly fractions on the table. So we're going to cross out all those ugly fractions. So we have an ugly fraction here, we have an ugly fraction here, and at 5 as well. So now we can actually plot these points. So we got 0, 4, so that's right here. Then we have 2, 5, that's right here. Then we have 4, 6, that's right here. And then we have 6, 7, which is here. Okay, now let's look at this graph here. So what math can we do to get to this nice number 5 from 4? We can add 1, and we can do that to get to every nice number. What about for the number of nights? What can we do to get to these nice numbered nights? Well, we can add 2. Well, if we look at our slope, which in this case is 1/2, okay, this is the math we did for our y's, or the top, right? We added by 1. Down here is the math we did for our x's. right? This is that 2 over here. These are common differences, okay? If you look at your graph, this number is positive, so it tells us to go up. This number is positive, so it tells us to go to the right. Those were the notes we took at the very beginning from up here. And look, from each dot, we went up 1, right 2, up 1, right 2, up 1, right 2. See that? Everything relates, the table, the graph, and the common difference, aka the slope. Our y-intercept is where we started. Well, we started with 4. Here it is on the equation, here it is on our graph, on our table, here it is on our graph. Okay, all pieces represent or are equal to each other. Now looking at the points that are left, can they tell you how many assignments she completes in how many days? So how many days does it take her to complete one assignment? Well, one assignment takes 2 days. And then it asks how long is it going to take her to complete 10 assignments? Well, if I just continue my table, right, we had 6 and 7. Well, every time we had a fully complete assignment, it took 2 days. So at day 8, we'll have 8 assignments done. At day 10, we'll have 9 assignments done. At day 12, we'll have 10 assignments done. And then look at that, it takes 12 days. Looking at number 2. All right, Michael brought his French Bulldog Tank to the vet, and the vet told Michael that Tank needs to lose weight, and he currently weighs 25 pounds, and the vet wants Tank to lose a third pound each week. So here's our equation, y equals 25 minus 1/3 x. The 25 represents his current weight. The minus 1/3 represents weight to lose each week. And then the x, well, if he needs to lose a third pound every week, then the x represents the number of weeks. So, looking at our calculator, again, we're going to plug in 0 here. And I'm not going to show the calculator, you can do it on your own. But we would get 25. If we plug in the 1 here, you should get 74 thirds. That's an ugly fraction. If you plug in 2, you should get 73 thirds. Well, that's an ugly fraction. If you plug in 3, you'll get 24. Well, there we go. We got a nice number. Now we'll plug in 4. Plug in 4, we get 71 thirds. Well, that's an ugly fraction. Plug in 5, and we get 70 thirds. Well, that's an ugly fraction. Plug in 6, and we get 23. Well, that's a nice number. So just like last time, let's cross out all the ugly fraction parts, because we can't really graph fractions accurately. Now let's look. To get to all the nice numbers for the number of pounds, we have to add by 3 for the number of weeks. Every third week works out. And every third week, this is where we see 25 to 24, well, that's subtracting 1. So every third week, he's losing 1 pound. Well, if I look at my slope, right, my slope, which is that number in front of x, well, that's a negative 1/3. We'll look at our table here. We're subtracting 1 for our y's, and we are adding by 3's for our x's, right? So that's where these numbers come from. Thinking about our movements from the other day, this negative 1 says we're going to go down. This positive 3 says we're going to go right. So let's look at our graph here. Let's see if that follows. We have 0, 25. So let's do the down 1, right 3 movement. So we're going to go down 1, right 3, plot a dot. Oh my gosh, do we have 324 as our next number here? We sure do. The movement matches. Let's do it again. Let's go down 1, right 3, and plot a dot. So that is 6 and 23. Is that our next plotted point here? It sure is. So again, all of them relate. We're going to skip D and E because we didn't do those in class, so I won't have you do them in the video. Looking at number 3 here, we have y equals 1 plus 3/4 x. What is the starting number? 1 is the starting number. What is our common difference? What's being added repeatedly? What is our slope? Well, that's the 3/4. We're going to rewrite it so that the x goes first. This is going to be y equals 3 over 4x plus 1. The 1's positive here, so I still need to show that here. This 3/4 x has the x, it stays with the x. So we know our table is going to start with 0, 1, but it's asking us what x values can we use, so we skip the ugly numbers. Well, let's look at our prior examples here. Looking at 2, we added by 3 and see how there's a 3 at the bottom of our fraction. Let's look at 1. We added by 2 and there was a 2 at the bottom of our fraction, which is our slope. So in this problem, the bottom is 4, so we are going to be adding by 4. So we got 4, 8, 12, 16, 20. Then looking at our y's, what do we got to add by? Well, let's look at the prior examples. We subtracted 1, and here we see that minus 1, right? See, here we see that minus 1. Here we added by 2. Here we see that positive 2 at the top of our fraction. So top of the fraction tells you the y's. Well, the top of the fraction here is 3, and it's positive, so we're going to add by 3. So this gives us 4, 7, 10, 13, 16. So for our graph here, we're going to start at 1. Then we are going to go, well, let's look at our graph here. Let's do this guy. This tells me to go up because it's positive, so I'm going to go up 3. This tells me to go right because it's positive because it's on the bottom. So I'm going to go up 3, right 4. There we go. And that point matches, this is 4, 4, this is 4, 4. So let's do that again. Up 3, right 4. Look at that. Now we can actually go backwards. If we went up and to the right, let's try going down and to the left. So start at your y-axis, go down 3, right 4, and see how that stays in line with our point. And we can do that another time, and it still stays in a nice straight line. Okay, moving on to number 4. We have y equals -2 minus 1/5 x. Our start value is the -2. And the number being added repeatedly, aka our common difference, aka our slope, is -1/5. Rewrite the equation. We have y equals -1/5 x minus 2. Once again, this -2 is staying a -2. -1/5 x stays a -1/5 x. The x is friends with the 1/5. Make it stay with the 1/5. He doesn't want to be friends with the 2. Don't make him. All right, here we start with a -2. For our y-intercept, as we go down on the x side, we're going to add by 5 because we have this positive 5 here. So we have 5, 10, 15, 20, 25. Up top here, we have a -1. You only use that negative once, so we're going to be subtracting 1. -2 minus 1 is -3. Then we got -4, -5, -6, -7. We start with that y-intercept, y of -2. So starting at the origin, go down to -2. It's going to be on the y-axis every time. Now, my slope here is telling me to go down 1 because that's a -1, right 5 because that's a positive 5. So let's do that movement. So we're going to go down 1, right 5, plot a dot. Down 1, right 5 again, plot a dot. Now I can't do that anymore. However, I can go in the opposite direction. So I can go up 1, left 5. So starting at my my y-intercept, go up 1, left 5, plot that dot. That dot's in line with my line. I can do that movement again, go up 1, left 5, that dot is in line with my line, and we're good. Okay, so now let's go to 5 and see how 5 and 6 on your paper, there's no more tables. So let's do this without a table now. So we have y equals 1/4 x plus 2. Our starting number is the 2. Again, it's always that number by itself. Okay? Then we have 1/4 as our slope. It's the number in front of x. This 1 is positive, so we go up. The 4 in the bottom is positive, so we go to the right. So starting at 2 on the y-axis, we're going to go up 1, right 4, plot a dot. Up 1, right 4, plot a dot. I can't do that anymore. But what's the opposite of going up 1, right 4? Well, the opposite is going to be going down 1, left 4. So why don't we do that? Starting at our origin, go down 1, left 4, and there we go. Let's do that in purple. Do it again. And both of those dots are in line with my line, so we're still making a straight line, so we're good. All right, number 6. We have y equals -3/2 x plus 4. Our y-intercept in this case is that 4. Our slope is the -3/2. Write it how you say it so that the negative is with the 3. Okay? There's only one negative, so you should only have one negative. A lot of students, when they see the negative, they assume it goes with both. That's not the case. If it went with both, there would be 2, but there isn't. There's only one. So you should only have one. Then the movement here, if we have a -3 up top, that says we go down. And if we have a +2 on the bottom, that means we go to the right. So starting at 4 on the y-axis, right? This is always on the y-axis. We're going to go down 3, right 2, plot a dot. 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 Now I can't go any further by going down 3, right 2, but I can do the opposite, and I can go up 3, and I can go left 2. So starting at my origin, I'm sorry, not at my origin, at my y-axis, I'm going to go up 3, right 2. Up 3, right 2. And look, both of those dots are in line with my line. So your homework is 2.8, and there are 4 graphs that you have to do. That's it, 4 graphs. So everyone, I hope you have a wonderful afternoon, evening, morning, and I'll see you next time.